to my channel, and today we're going to be doing problem G from AtCoder DP called longest path. Okay, so let's see. We have directed graph, n vertices, m edges, n and m are both at most 10 to the power 5, and we have these vertices, and there's no directed cycles. Okay, that should be important. Right, and we need to find the longest direct path. So there's no direct cycles. If there was a cycle, then, depending how you would define it, it could be infinity, it could be whatever, but that means that, we never have to worry about anything going back on itself, right? We can always go fully to the end. Okay, so essentially, if it's a directed graph that doesn't contain any directed cycles, then that simplifies the problem a lot. It's not quite a tree, of course, but it does simplify it a lot. Okay, so let's take this right here. Let's take this input, okay? We'd say 1 goes to 2. It also goes to 3. And 3 goes to 2. Okay, 2 goes to 4, and 3 also goes to 4. So let's see, right? So from 4, let's say that's like the origin, right? The longest path is 0. Right, so this is clearly 0. I mean, we can't go anywhere. 1, it is, you go through here, you go through here, you go through 4, okay? So that's 3. 2, you just, I think the only place you can go is 4, so that's 1. 3, the longest, is going through 2, going through 4, it's 2, and there we go. So let's see how we can do this. Of course, the crudest way of doing this is you start from any edge, okay? So you start at any edge, at vertex I, and then do like a DFS, right? DFS or BFS shouldn't matter, right? And you go through. So, and there's no cycles, so nothing to worry about. So this can take, up to n. So the O of this would be n squared, right? Because you'd potentially be going to up to, all of the vertices in your path. Okay. So let's see, right? So that's clearly too much, right? If it's 10 to the power 5. So let's see what we can do. Right? So in the classic DP fashion, how can we use prior, knowledge, right, to help figure out, what our next direction is going to be, basically. Okay, so since there's no cycles, nothing, so what we can try to store is we can store DP for, each vertice. We can try to find the longest path, okay? So how can we reuse information, right? So if you want to do some type of DFS, what would be redone, right? So let's look at this graph right here. If we do some type of DFS, right? From 1, we go, from 1 you would go, you go here, you go to here, 3 would go here, then you go here. You'd also explore this path here, right? And, this would go, okay, this would be 1, right? 3, this way is 1 length. But 3 you also grab from here, so that's 2, so maximum of 3 is 2, and so this is 3, right? Maximum of 3 plus 1 and 2 plus 1, okay. So I think we can see how, I think that's pretty clear how that would relate to, what's my DP for 2 and what it is for 3, right? So if we say, all right, was my DP for 4? It's clearly 0, right? So 4 is like a child of 2. So 2 is just, because 4 is its only child, it's just DP of 4 plus 1, which is, 1. Now for 3, it has 2 options. So the longest path from 3 is equal to the longest path, either the longest path from 1 or the longest path from 2, right? So it's the max of that plus 1. So I think you can see how we can deal with this, all right? So essentially all we have to do is we do a DFS, all right? And every time we calculate the value for a node, right, we will store that in DP, right? So you'd have some DFS function, you've had the vertices, you'd be, for all children, DFS, right? And then, you would return max of all these plus 1. But now all we do is we store this in a DP for V, and if, all we do here is we check if there's already DP, if you already calculated, then you just skip, right? You just already return DP, okay? So all this means is that you only have to calculate this value once. So you just have to run this function once. You only set a value once, right? For each node. So now O of n is 0. So this is another classical DP problem, which is just using graphs. I hope this is helpful. Thank you for watching, and I'll see you next time.